Hi, welcome to the first introductory demo on the R programming language. So in this video, we're going to be covering how to do arithmetic in R, how to work with variables in R, how to work with a specific kind of data object called a vector, and how to work with mathematical functions, and how to work with a data object called a data frame. Okay, so the first thing that you're going to notice is that your screen, what we're looking at is RStudio, which you've already downloaded. So you're looking at four panels. You're looking at a top left panel, a bottom left panel, a top right panel, and a bottom right panel. So the usage of these panels will become more clear as the demo continues, but generally speaking, our scripts are up here on the top left. The top right, we're going to see a list of what our variables are and some information on those variables. The bottom right, we can use to visualize our plots. And the bottom left is the console, which is really the R computer. It's the actual R programming language down here. Um, we could type things here directly into the console, some input, and it'll produce output. But generally speaking, we downloaded RStudio so that we could have some extra tools to be able to write code, one of which is these scripts up here that we're going to look at in a minute. But let me show you how this works. So the bottom left here, we have the console, and the command line is where this blinker is. This symbol here, that arrow, is pointing to the blinker and is showing you, hey, you can put a command in here. So let's do 3 plus 3 and then hit enter. So it brings back 6, okay, which is correct, obviously. Later I'll explain what this one inside of the brackets means. We could also, in the command line, if we put things in between quotations, write messages here. Hello, Psychology 230 Lab students. And hit enter, and it prints it. And again, you can see that there's a little box with a number 1 here. So in R, we could work with numerical data, but we could also work with letters and words and qualitative kind of data. So this is the R programming language, but RStudio enables us to be able to, in a more organized way, write our code. So let's look up here in the top left box. You'll notice that everything is written in green. So, and you'll also notice that there's a bunch of hashtags here. So on line 1, you'll see that there's a hashtag and it says R intro demo 1, which is the title of the script. So let me erase this hashtag. Notice that it now it's this black words and there's an X here. That X is telling you that, hey, this is code and there's something wrong with this code because it's not written in the proper syntax. Like, I'm gonna run this code by highlighting it and then hitting this run button. And you can see down here in the output in the console that it says unexpected symbol and R intro demo. That's because this isn't proper syntax. This is just a note that I left for you guys. So I'm gonna put this hashtag here. Now the R computer isn't going to read this line. So R will ignore everything that's to the right of any hashtag. So if you want to write yourself little notes or messages or reminders or things like that, you can hit a hashtag. You can put it to the right of a hashtag, and R will ignore all of that. So you can see here in lines 3 and 4 that I have 3 hashtags. So the convention that I'm using for this demonstration and in my scripts is that whenever I write 3 hashtags, that means that to the right of that I put some instructions or some explanation of what's to follow. So here I've put clearing the console, use Control L. So if you notice back here on the bottom, there's some stuff in the console and I want it to look clear, so I'm going to click on the console hit Control L, and that clears up the console. So it enables me to get a nicer visual of the output. If you go back up to line 3 in the script, it also says removing the global environment to the right, use, and in the parentheses I have RM with this these open and closed parentheses, or, and then I have this other phrase here, right? The global environment is here to the right that I mentioned, where our variables are going to be listed. Sometimes this area gets cluttered too, or you don't need certain variables. You can just remove them with this function here that's listed on line 4. So generally speaking, in R, we have functions that take some kind of input, they do something to it, and then they produce some kind of output. In this case, this RM stands for remove. So if we put something in an object inside of this function here, it'll remove that thing from your global environment. Later on, we'll get an example of how that actually works. So if we continue scrolling down, here in line 7, you can see that I have some other instructions. I have 3 hashtags, and it says arithmetic. Okay, so here I'm showing you that in R we can do adding, we can do subtracting, we can multiply by using the star, which is above the 8. We can divide by using a backslash. We can do powers by doing 2 of these stars, or by using the caret symbol, which is above the 6. And R follows the order of operations, obviously. So these are instructions, and in my script here I put another little mini instruction that says erase this and try. So let me show you how a script would work and how you would write code in the script. So I could put, you know, I already showed you addition. Let's do a division, right? So let's do 10 divided by 5. And then I'm going to highlight this and run this code. So I get 2, right? Let's do, I can erase this, and on the same line, I can do maybe, let's show you how the powers work. So 2 to the 3rd power is 8, so let's do 2 to the 3rd power. I'm going to highlight this and run this code. And you can see on the bottom in the console my output is 8. So let's do it the other way. I said you could also do it with a caret. So 2 caret 3 is the same thing as 2 to the power of 3. Let's run that. And you can see that my output says 8. Okay? So also we can do order of operations. We can do 2 plus 3 times 3. And it'll multiply first and then add. So let me highlight this line and then hit run. So as you can see, my output is 11, which is following the order of operations. So generally speaking, we work from the script and we highlight lines that we want to run. You can also run the script at once, but oftentimes what scripts work because we can focus on particular lines, and this helps us to debug. And in general, RStudio, which is called an interactive development environment, or an IDE, wraps around the R computer, and it provides us with many different tools that we'll be using that are practical. The R computer in and of itself, if you would have just downloaded R and just used R, would look like the the console down here on the left. It would basically just be a little black box with the command line and input and output. Let's clear this real quick by hitting Control and L. Okay, so let's talk about variables and variable assignment. Okay, so you can work with letters and with numbers in R. So let's show you how variables work. So on line 12, I'm going to put a variable x, and I'm going to do the less than symbol followed by a dash, creating a little arrow, and then I'm going to put something in there. So I'm going to put the number 5 in there. Okay, so this is on 12, this line is saying that the number 5 is going to get stored into the variable x using this assignment operator that I've created, a left arrow. Okay, so let me highlight this and run this code. You can see on the bottom here that it showed you that it ran the code and it put X here. On the right, in the top right, in the global environment, you can see that I now have an X value here and that it has a 5 in it. So on line 13, back in the script, I'm going to put X and I'm going to highlight this and then run this. So I'm putting X, and then as you can see, it now returned that value. So it returned the value number 5, and I could even run it from the console. I could even just put X in the console, hit enter, and it returns the value that's inside of X. Okay, so we can also sequence numbers. Okay, so we can put a sequence of numbers in the variable. So let's create another variable here in my script on line 14, and I'm going to do the assignment operator. Now I'm going to put the numbers 3 to 6, and notice that I put a colon in between the numbers. That means that it's going to give me the sequence 3 to 6. I'm going to highlight line 14 and hit run. You can see on the right that I now have Y, and it's telling me that I have 3, 4, 5, and in the brackets it's telling me 1 through 4. So 1 through 4 refers to the particular index, its position within Y of this number. So it's telling me that the first position is 3, that there's 4 positions, and position 1 corresponds to 3, position 2 corresponds to 4, 3 to 5, and 4 to 6. So let's look at the script. Let me put Y here and then just run this line 15, run Y. And you can see that my output on the console is 3, 4, and 5, 3, 4, 5, and 6. Okay, so now we know that that there are positions within within these variables. Okay, so if you look at line 11 here where I put the instructions, I also mentioned that you can do variable indexing with square brackets. So I'm going to skip a line here, and I'm going to go on line 16, and I'm going to put the Y with a square bracket. Now I'm going to put a number in here, and you probably guessed it, this is the index, and when I run this code, it's going to return the number that is indexed at that particular index. So let's return the number 5. So that should be indexed at the 3rd position. So I'm going to highlight line 16 and run this, and you can see on the bottom here that Y, it's the thing that's in the 3rd position is the number 5. Okay, so that's how indexing works. Let me clear the console here by hitting Control L. Now I can view it more easily. And let's go back to our script and look at line 18. So now I'm going to talk about vectors. You just saw an example of a vector. So when I created Y and X, those were actually vectors. The vector is a kind of data object. It is an object that can be manipulated in the R programming language, and it can contain values. Okay, so if you look at line 19, here I just mentioned to you that you can create a vector, and this is the way that vectors are usually created in R, using this function called the C function. So it's just the letter C with an open and a closed parentheses, and this is called the concatenation function. Concatenation means that you're putting things together, you're concatenating things. So this function is putting together a vector of values. So this function takes values that you can separate by commas, and I'll show you here in a minute. So there are various types of data classes that are found in R. So data classes, and I'll just show you a couple here as examples, but there's many of them. You can have a character kind of a type, you can have a numerical class, and you can have a categorical class, amongst many. And I'll show you here an example of each. But really quickly, I'm not going to need this X and Y variable anymore for our demonstration, so I'm going to use that remove function that was mentioned here at the very top of the script in line 3, or line 4 I mean. So I'm going to go just to my console, and I'm going to put rm, open those parentheses, and I'm going to put x. Okay, so I'm going to hit enter, and as you can see on the right, it removed x. So also on line 4, you notice that I put another expression here, and that's rm, but inside of that we have another phrase that's list equals ls with the open and the close parenthesis. So this entire thing will remove everything that's in your global environment. So I'm going to use this to remove y right now, but if x and y were both in there, it would have removed both x and y. So I'm just going to copy and paste this and paste it down here in my console and hit enter, and that removed the y. Now I'm going to clear my console again. Okay, so now let's go back and talk about vectors. So like I mentioned before, there are many types. We're going to look at 3 right now and create 3. So let's look at a character vector. If you look at line 22, you'll see that I have subpoint A, character. So we're going to create a character vector by using the concatenate function, and separated by commas we're going to have our various characters. Okay, we're going to put our characters in parentheses. As I mentioned earlier, you can write text inside of parentheses, and that's how we're going to do our character vector. So we're going to create a vector here. On line 23 I have an example that I already wrote. It's I'm going to unhashtag this. You can see here that let me separate this by the space so you can just focus on this. You can see here that I'm creating a vector that has the names Jackie, Jill, Scott, and Chris. So I'm going to highlight this and hit run. So it's here on my global environment to the right, and you can see that it contains Jackie, Jill, Scott, and Chris, and it has an indexing. And just to show you that indexing works the exact same way, on line 25 here, I'm going to pull out the third name, which should be Scott. Okay, so I have names indexed at 3. I'm going to hit run. You can see here on my console on the bottom that it printed out Scott. Okay, so you can index vectors no matter what's in them. So let's create another vector here on line 27. I have subpoint B, and it says numeric, so we can create numeric vectors. This one's going to represent the number of pets. So I already created it on line 28. I'm going to unhashtag this, highlight this, and hit run. It appears in my global environment here on the right. So let's go to line 30, and we're going to create another numeric vector. This one's going to be GPA. So I'm going to unhashtag this vector I created on line 31, highlight that, and run that particular line. It appears in my global environment here. And then lastly, we're going to create a categorical vector, and this is going to be a little bit more complicated because categorical vectors require 2 steps. Okay, so you can see here on line 33 it says subpoint C, categorical. Use, and then I have a function here that says as factor. Inside of it, you can see that it, actually I'm going to erase this other little part here. I think that'll just be, that's unnecessary right now. I'll explain that later. So you can see here it says categorical, and I'm using this function as factor, and inside of it I'm putting some vector. Okay, I'll even name that some vec, as for short for some vector, any random vector. So this as factor is going to take that vector that's going to have a character type, and it's going to convert it into a category. So here I'm going to create a gender vector, and as you know, gender is a categorical variable, right? It's a nominal variable. So I'm going to create this vector, and I'm going to run this code. You can see here in the global environment on the right that the kind of vector that is listed is character, right? And Jackie and Jill, that was a character vector. Petnam and StuGPA were also numerical vectors, and they're specified here. So this is, gender is technically, I want it to be a categorical vector, not a character vector. So I'm going to use this as factor function and then put the gender vector inside and then assign that, all of that result, into that same gender vector. Okay, so I'm really just changing the type from character to factor. So factor is another word for categorical, but in R it's just called factor, not categorical. So I'm going to run this code. And look to the right, you'll notice that now it says factor with two levels, female and male. So as I mentioned in class, sometimes numbers represent categories. So don't be confused by that. Here, female was coded as the number 1 and male was coded as number 2. So these numbers are just used by R to differentiate between various categories. And it'll assign the numbers to the categories by alphabetical order. So that's why female is coded as 1 and male is coded as 2. Okay, so and the reason why we had to do a two-step process for categorical variables is because you can have categories that have weird funky names, like maybe your categories are countries in North America and you have Canada and you have United States of America and then you have Mexico. And so basically, since categories can have any kind of name, you first have to input them as characters, and then you have to transfer those character names into particular categories by assigning those numerical values to them. Okay, so now back to the script. You saw how we created various types of vectors that can contain various types of variables, some of the variables that we already talked about during class. Before finishing up with our final topic, data frames, I wanted to show you very quickly how math functions work in R. But I wanted to demonstrate the idea of a vector before I did that, and that's why I kind of sticking this section in here. So look at line 38. I have the fourth topic is math functions. 39 and 40 tell you which ones I'm going to demonstrate, and actually the second one is diff. Let me put that in there. Diff, which is a difference, minimum, maximum, square root. Okay, so line 41, I'm assigning this vector. It's got these numbers here. I'm going to run that. Let me have this practice vector. Then I'm just going to copy and paste this vector in and put that vector in all of these functions and just run them real quick for you. And that'll be it for the math functions, and just so that you can see that it performs all of these functions. So let's copy and paste that, put that in here, copy and paste, copy and paste, copy and paste. Okay, so let's start. Okay, and then we'll run the range. Okay, so let's highlight all this and run all this. So, so we can see here in the output, we have practice vec, and then the sum came out at 12. The difference, so the difference will give you the difference between two numbers, but when you put more than one number, it'll subtract the leftmost number from the right. So if you notice up here, my practice vector had four digits, four numbers I mean, so it was just subtracting, it subtracted 3 from 4, that's why the first output is 1. It subtracted 4 from -5, that's why the output is -9, and so on. So down here we have our minimum, -5, we have our maximum, which is 10, we have our square root, and notice here that it returned the square root of 3, the square root of 4, which is 2, and Negative numbers don't have square roots, so it produced a nan, which means not a number. Um, and then 10, square root of 10 is 3.1. And it told you that it produced a nan, so it gave you that warning. So obviously a square root can only be run on a positive number. So AVS stands for absolute value. So notice that what it returned down here was the absolute value of all these numbers. There's a negative number and it returned a positive 5. Okay. The range returned the lower limit and the upper limit, not the actual distance between them. If we want to do that, then you got to look at line 49 up here in my script. So I can use the range, so that gives me the upper and lower limit, then use the diff function on that. So this demonstrates that you can nest functions inside of other functions. So let's run that, and that'll give you the range, okay, and the output there on the bottom. So let's highlight some of these. So these last four are obviously very beneficial for us in the statistics class. We have the mean function, the median function, the standard deviation, and the variance. So let's run these, and our output here, it'll produce the output of all these, okay? So that's how math functions work. There are very quick ways of getting some of those estimates for some of your numbers, okay? So let me clear the console, and now we'll actually go to the last topic, which are data frames. So we've been building up so that I can show you what data frames are. They're a kind of data object that R can manipulate, and they represent our table, right? Our typical table that will have columns as variables and rows as observations. So on line 57, you can see that I've put here data.frame with the open and close parentheses. That's the function that will make you a data frame. So my example here is, this is my example data frame that I would be creating, my data frame, and I have the assignment operator here, and notice that I have the function data.frame, and notice that I have var1, var2, var3. That's short for variable 1, variable 2, variable 3. So in general, you would put your variables in there separated by commas. So let's make a practice frame on line 58. My practice frame here, I've called it practice frame. I could have called it whatever I wanted. And you can see that I'm assigning this by using the data.frame function. So I already have these variables up here that I created. So may as well put those into a data frame. So the order that I put them in will be the order that they come out in the data frame, with the first one being the one to the variable that's most to the left in the table. So let me highlight this and run this. Notice now that in my global workspace I have under data, it says practice frame, and there are 4 observations of 4 variables. And obviously my values here for my variables are still down here. So just so that we can see what it looks like, let's just run the frame itself here in line 59. I'm going to highlight practice frame and then just run that. And see here in my output, I have my little mini data frame. It's got 4 observations, that is to say 4 rows, and 4 variables represented by the columns. Okay, so now we can see how data frames work. Let's practice getting information, particular information from a data frame. So this is called subsetting, because we are taking a subset of that entire data. Line 61 is where I begin my instructions. So there are 2 ways of subsetting data. You can do a subset, and I've listed here on line 62 as a subpoint A, by taking your data frame and then using the dollar symbol and then followed by the variable name. Okay, so you can pull out whatever variable you want that way. Let me show you an example of that very quickly. I'm going to just run that down here on the bottom of the script, and I'm going to do all those here on the bottom, okay? So I'm going to do a practice frame $, and say I just want to pull out the and notice here I put the $, and a little box pops up with all the possible variables. So I can pull out whichever column I want. So let's pull out the names. Okay, so I'm going to highlight that, run that code, and my output is Jackie, Jill, Scott, and Chris, which are the values in the column names. Okay, so obviously I can change that. I can put whatever variable name I want. I could maybe do gender. So let me highlight that and then run gender, and then you can see it pulls out the gender, and it tells me what levels there are. And gender is a categorical variable with 2 levels, the male and the female level. Okay, so you can also use the square brackets to pull out a particular value specifically, not just the whole vector, but a value within that vector. So let's pull out the GPA of Jackie. Okay, so we're going to go to do GPA. So we're going to pull out GPA, and then within brackets pull out that that first variable. So and it pulls out 4.3. Let me clear my console. So you can extract particular items within a vector. Okay, so that's A. So that's the demonstrating how to subset using this first method. So let's look at B here on line 65. You can also subset from a frame using the convention of the brackets. Okay, so let's read the instructions on B here. So it says my data frame, and then it has the brackets, and it says row, and there's a comma, and then column. Okay, where row and column can be integers, they can be sequences of numbers, it could be vectors with numbers, or it could be logical operators. And those are just some of the things that we can do and how we can subset an index. But let me show you some examples of what exactly that means. Okay, so on line 70 I have my practice frame, and okay, so first of all, if I just put a number, let me pop up my practice frame so you can see what we're looking at. So I'm gonna print it to the console so we can see what it looks like, and I'm going to just put a number in there. Okay, so what happens if I just put 2 in here? So I'm going to run that and hit it, and what returns is the second column. So if you just put a number in there, it's like you're telling it, oh, an index for one of the variables. So return the variable that's indexed at the second position within that data frame. Okay, so but notice here that I said that the convention is to put a row in a column. Okay, so I just wanted to show you that if you just put a number in there, it defaults to returning the variable. Okay, so let's do something with the comma. Okay, so let's extract oh, and by the way, like when we're thinking about like matrices, when we're thinking about data frames or tables, we're always talking about a row and a column, right? So we could have like the second row, third column, and so it's when we represent them by numbers, it's always row, column. So let's extract the second row. Okay, so here I'm not even going to put, I'm not going to put anything for column. Okay, so let's see what happens if I run that. So it literally gave me the entire second row. I didn't specify what column, so it just gave me all of the columns, right? So it gave me the second row and every single column because I didn't specify. So what if I do specify? What if I put the fourth column? Okay, so let's run that. So that returns the value that's in the fourth column. So now I'm looking at the second row, fourth column. So that's how, let me clear my console and put up another practice frame real quick so we can have something to look at. Okay, so that's how indexing works. Okay, so the left spot is for the row and the right spot is for the column. If you leave anything out, like if I were to leave this 2 out, let's see what happens real quick. So I'm going to leave the row spot out, hit run, and what you can see is that you get back the whole fourth column and all the rows of the fourth column. Okay, so let me clear that again real quick and put up my practice frame. So I also mentioned that you can put sequences. So let's say that we want a sequence that includes the first two rows and the fourth column. So we could do practice frame, the sequence of 1 to 2 in the fourth column, run that. And so that returns the first two rows in just the fourth column, right? And obviously if we don't specify a column, it'll just return the first two rows, all of the columns of the first two rows. So we could do that. Obviously we could put a sequence for the columns as well and then produce a sequence of columns. Like we could do the first two, right? Obviously we could do the first two columns and the first two rows of the first two columns. And that's going to return the first two rows, Jackie and Jill, and the first two columns, which are name and gender. So if your columns are not next to each other, we can just use a concatenation and say, hey, look, I want the first column and the third column. Okay, so then I can run that, and it's going to return the first two rows of that first column and the third column. You know, or you want all the rows of the first column and third column. So let's just do practice frame with the row spot empty and the first and the third columns. Okay, so that's exactly what it returns to us. Okay, so this was just I intend this to be kind of an overall introduction to how art works. I have not even shown you a fraction of the capabilities that R has. There's even way more ways of a setting. Actually, I'm going to show you one more real quick. So let's say that I want, I also said that you can use logical operators, right? So that's double equal signs means that two things are going to be equal to each other. An exclamation mark with an equal sign means that things are not equal to each other. This is less than or equal, greater than or equal. You can also do greater than, less than, and I'll show you how that works right now. So let's say I want my practice frame, and command paste. So let's say that from my practice frame, I want to pull out all of the rows that where the participants are female. So this is how I would do that, and I want to pull out all the columns as well. Okay, so I'm going to put practice frame, oops, with a capital F, frame, and then the dollar sign, and then I'm going to put where the gender is equal to female. Okay, so notice that I put this in the row position, right? So the column goes to the right of the comma here. So this is telling it that this command is for rows. Okay, so notice that I use the syntax of a variable. So I put practice frame variable, which is the column, right? But I'm saying like, hey, run the rows that I want you to return are going to be the ones where you notice that the variable of gender has female. So let's run this real quick. We run it, and yeah, and it returned all of the columns, right, where the gender variable is equal to female. Okay, so let's say that I wanted to return all the columns where the gender is equal to female, and the pet number is greater than 0. Okay, so let me clear my console real quick, just so that you can see it more clearly. Print. Okay, so here's my data. Let's do female. So I'm going to put n, and I'm going to put practice frame where the pet number is greater than 0. Oops, 0. Okay, so now my rows are going to be subset by not only whether it's female, but also whether the variable of pet number um, is greater than 0. And notice that I connected those two logical operators with this AND symbol. Okay, and again, the columns is going to be all the columns. So let's run that code. And you can see that it returned Jill because she's a female who has pet numbers greater than 0. So obviously you can use logical operators in the column section as well. I don't want to give you too much information for this first tutorial. So that's just an introduction of how subsetting works and how data frames work. Okay. So in the next video, I'm going to show you, it'll be a much smaller video, which will show you how to make graphs in R. Okay, so I hope this should be enough to kind of get you understanding how R works and how this particular programming language works. So I'll see you in the next video.